In this video, we will discuss synthetic division. Synthetic division is an alternative to long division, but can only be done with certain types of polynomial division. And it's when the divisor is a linear binomial. Okay, so again, linear binomial. Linear means that the largest degree term is x. In other words, there's no x squared, x cubed, x to the fourth, so on and so forth. It's just simply x, but it has to be there. There has to be an x term. You can have a coefficient of x, that's possible, and it's going to be either plus or minus some constant c. So again, that's a, the coefficient, times x plus or minus some constant c. That will be your divisor for all problems that you can do synthetic division with. If it doesn't look like this, if the divisor does not look like this, you can't do synthetic division, which is why we still need to know long division for certain problems later on in college algebra. Each of these problems we will divide, but divide synthetically, and we first need to make sure that these divisors are linear binomials, and both of them, since they are the same, are the linear binomials. Now, second of all is the setup. The setup looks a little differently. So you're going to start with this backwards L, and you're going to make a horizontal line segment underneath it, and we're adding vertically here. Now, the thing that goes in this backwards L right here, you're going to set this x plus 3 equal to 0. So in other words, set the binomial equal to 0 and solve. So you get x is equal to negative 3. That value is what goes inside the backwards L. Now, to the right of the backwards L is going to be your coefficients or your constant in the polynomial that you're dividing. So it'll be 1. Here's a 4. Now notice here we're skipping some terms, so we need to represent those in our problem here. So we have a 1 followed by a 0 for x to the fourth, followed by a 4, followed by 0, followed by 1. This would be the linear term. Followed by 0 again. We have a constant there we'd still need to represent. Now we're going to add vertically. So we start off by adding vertically. And 1 plus nothing is 1. We then multiply diagonally. So negative 3 times 1 is negative 3. Add vertically, which is negative 3. Multiply diagonally, which is then positive 9. Now notice here when I multiply, I'm going to put the product underneath the next term. So I have positive 9. Add vertically, which is 13. Multiply diagonally, which is negative 39. Add vertically, which is negative 39. Multiply diagonally, which is a positive 117, add vertically, which is a positive 118, and then multiply diagonally, which is negative 354. I add one more time, which is negative 354. Now, to find the final answer, what I suggest you do is start, especially until you start seeing the pattern, start on the very end. So the very last term is your remainder. So this is a remainder of negative 354. The very next term is your constant, so I'm going to start with plus 118. Then the next term is going to be your linear term, which is with your x, so negative 39x. The next term is with x squared, so it's plus 13x squared. Next term is x cubed, so negative 3x cubed. And finally, the last term is your x to the fourth, so it'll be positive 1x to the fourth. And so that is your final answer when you divide x to the fifth plus 4x cubed plus x, when you divide that by x plus 3. We'll do the same thing with number 2. And again, we're going to have that backwards L. We're going to have negative 3 inside that backwards L because it's really the same divisor. Next to the backwards L, I'm going to have 2, then 5, then remember negative 2, positive 2, negative 2 again, and positive 3. No zeros here because we have every single term represented. Again, this is all about the pattern. So I'm going to add vertically, that'll be a 2. Multiply diagonally, that'll be negative 6. Add vertically, that's negative 1. Multiply diagonally, that'll be positive 3. Add vertically, that's 1. Multiply diagonally, that's negative 3. Add vertically, we have negative 1, multiply diagonally, and you get positive 3. Add vertically, you have positive 1, multiply diagonally, you have negative 3, and finally, add vertically, you have 0. So now I have a remainder of 0. We have 1 as my constant, positive, negative 1x as my linear term, positive 1x squared as my quadratic term, negative 1x to the third, and then finally I have 2x to the fourth. Now notice here's just a quick special note. Because this is a remainder of 0, that means that this x plus 3 is in fact called a factor of this polynomial. All right, what that means is that that long polynomial can be rewritten as 2x to the fourth minus x cubed plus x squared minus x plus 1 times this x plus 3. So again, if you have a remainder of 0, that x plus 3 is actually called a factor of that polynomial. When it's not a remainder of 0, it's not a factor.
What's up, Zach?